DNS would not understand the different scripts, but we still have to convert those scripts into ASCII format, and that's what you see over there, an ASCII character set. And so that's basically an IDN. So you can see that with all these different, over the last 30, 40 years or so, the domain name system, the DNS, has evolved quite a lot, especially the top level domains has increased up to currently over 1,500 or so, right, top level domains. And then we go to the next level, which is what we call the second level domains, and then the third level domains, and so on. So for example, if you want to visit a website called www.example.com here, right, www.example.com, basically, I mean, you wouldn't care about all these things. When you type that in your browser, right, or even probably you don't type anything, you might just open your mobile app, right? But actually, the client software or the client resolver that you have will have to do what we call a query, DNS query, based on this hierarchical structure to find where or what is the IP address of that particular web server. Because earlier we talked about these unique identifiers. Behind these domain names, we have an IP address. We don't type IP addresses in your browser because as humans, we don't know, we can't remember these IP addresses. If I ask you, there are many organizations here, if I ask you how many of you can remember your company web server IP address, not many people can remember that. But if I ask you, okay, what's your company website or the web server, then people can easily remember that. So that is why actually, we don't really, as humans, we don't really deal with IP addresses much. But as general users, humans, we can easily deal with the domain names, the names, right? We can easily remember that. So that is why the DNS will provide a mapping between these names and the numbers or the IP addresses. So that's why we have to put these domain names into a proper structure, like in this case, a hierarchical structure, properly delegated so that there is a proper structure behind DNS. So we have the root, the top level domains, the second level domains, third levels, and so on, and that's how the DNS structure is being built or designed. Now, one thing what is important for you to remember is that all those, say the TLDs or the second levels and so on, they keep a certain space, right? So if I take .com, .com is a space or a database, or .net is a database or a space. .mp is a space or a database. And this database has to be kept in a server called DNS server. So that's what we generally refer as a DNS server. So these DNS servers, they keep these databases. Specifically to say that these servers are called authoritative servers because they are authorized to give reliable answers about these spaces. Okay, so now moving on. So how the DNS work, right? You can't see the title here, but the title says, okay, how DNS work. So in terms of, say for example, you have an end user over there, and that end user would type a domain name here, www.example.com. You are the client. So this query would go to what we call a recursive name server. So typically, these recursive name servers are maintained or managed by the service providers, like ISPs. So if you are a user at home, most likely you will use your ISP's DNS recursive server. That's what sometimes we call it as a local DNS server. So your query will go from your device to your ISP's recursive server. In a corporate environment, sometimes the companies, banks, and so on, they may also decide to operate their own corporate recursive servers for their clients. That is also possible. Sometimes we use public DNS servers, public DNS recursive servers. There are various companies out there who provide these recursive name servers as a public service. So whatever the case, we use different kind of recursive name servers for us to do our DNS queries. So these DNS queries would go into these recursive name servers, and then the job of this recursive name server is to now find an answer to the client. So basically now client is asking, I want to visit www.example.com, which means the client needs actually the IP address of www.example.com, because if the client doesn't know the IP address, it cannot go to that web server and download the web page. So the client needs to know the IP address. So now the recursive server has got a job. The job is to find the IP address of www.example.com. So what the recursive name server do is, it will traverse through that tree hierarchy that I mentioned you before. So the query would go to the root servers, because root means root servers keep the root database or the root zone, and then the root would give a reference to the next level or the TLD level server, and then the TLD level server give a reference to the second level server. So in this case, root will give a reference to .com, and .com will give a reference to example.com. And when the recursive server goes and talks to the example.com server can exactly provide the IP address of www.example.com. So that's how the recursive server gets the IP address of the web server and then return back to the client. So this is how a simple DNS query gets resolved. But now, the question is this secure? Right? So we do these queries all the time. Now the question is whether these queries are secure. Can you believe if this example.com gives the recursive server an IP address, okay, you go and visit this web server, can you believe that you receive the correct IP address? Because if you receive a wrong IP address, you may end up in going to a wrong place, right? And people can purposefully do this. There can be various security threats related to this whole scenario. So that is why actually the whole purpose of DNS security is important in this regard. So if you specifically look into the components of the domain name system or DNS, you can see there are a number of components here. One thing, of course, our resolver, the client resolver itself, if you use a mobile phone or a laptop or any device, right, or even any IoT device for that matter. So these are all stub resolvers. So stub resolvers are built into these clients. And then we also have recursive resolvers, typically managed by the organizations that I mentioned before, like ISPs or public domain DNS servers, or even corporate DNS servers and so on. And then also we have all those other authoritative servers that I mentioned before. Root servers are authoritative for the root zone, and .com servers are authoritative for .com zone, or .np servers are authoritative for .np zone. So these servers are actually called authoritative servers. So the queries, the recursive servers, that means they all go and talk to various of these authoritative servers and get the authoritative answers, and these answers are returned back to the client. So these are the main components that we see in the DNS. Now, if you see where we are vulnerable from a security point of view, so if you manage this DNS infrastructure, right, where can someone attack you, right? Where can you get attacked? Where are the risks involved? So these are the places that you have to protect, right? You have to be aware. Now, as you can see, actually, I put all those in red text just to say that these areas can be vulnerable, right? So this is why we have to pay special attention in terms of DNS security. So for example, the recursive resolvers or the recursive servers, they are the ones who are are basically serving the client. So if the recursive servers or recursive resolver is being hijacked, right, then definitely there's a problem. These things can happen. For example, when we travel or when we are in public places, right, we use sometimes if we see some free Wi-Fi hotspots and so on, we connect to those, right? So when we connect to those, that means we are using those infrastructure, right? So if we are in a public place, we connect to a hotspot, that means we are using that infrastructure. So our queries could be going to their DNS servers, right? But can you trust that, right? So these are the questions that we have to ask us, right? And so trust is very important in this whole DNS context. And these servers can be hijacked. Or one of the other problem is that these recursive servers, the caches means actually the answers that it keeps in the memory. These caches can be poisoned or polluted. So for example, now if I am a recursive server and you ask me, okay, give me www.example.com. So I will go out to authoritative servers, the root servers, TLD servers, and so on, and I will find you an answer. I will basically find the answer and give the answer to you, right? Because you are the one who is asking me that question. You are my client. So when I give you that question, the thing is that in case if someone has poisoned my cache, so if someone has managed to change that answer to something else, then there's a problem, because now I'm giving you a wrong answer, so wrong IP address. So you're going to visit a web server but by thinking that you are visiting the right website, but you may not be visiting the right website. You are visiting a wrong website. But actually, look and feel could be same. Maybe if it's a bank website, the look and feel could be the same. Maybe